Hello my dear friends, welcome back to my YouTube channel. This is Vipul Purohit and I'm going to discuss in this particular session about zeotropes and azeotropes, and then later on slight detail in what exactly azeotropes are all about. So here we begin. Zeotropes, mixtures which do not show maxima or minima in the vapor pressure composition curve. Okay, maxima or minima in the vapor pressure composition curve are known as zeotropic mixtures or zeotropes. Previously, my dear friends, I had uploaded a video on the deviations from Raoult's law. So there I was talking about the positive deviation and the negative deviation. Okay, so positive deviation means it is more, the experimental value is more than the Raoult's law. Minima means it's going to be less, negative deviation, less as compared to that of Raoult's law. But here it says it does not show, do not show maxima or minima. That means its values are in agreement with that of the Raoult's law. And therefore we say there is no deviation, and therefore we say they should be ideal solutions. The examples are nitrogen, methane. Next we have is ethane, propane. And next we have is butane and isobutane. Alright, so this is about what do we mean by zeotropes. Alright, we move to the next segment, and that is azeotropes. Mixtures which show, okay, can you just see this? It shows maxima or minima in the vapor pressure composition curve, and they are known as azeotropes, or we call it as azeotropic mixtures. So my dear friends, you can, if it is a maxima, so it's a positive deviation. If it's a minima, so it's a negative deviation. But in any which ways, it shows deviation. And when I talk about deviation from Raoult's law, so obviously it's going to be non-ideal solutions. So here the example that can be considered are ethanol and water. Next we have is ethyl acetate and water. And next we have is water and cyclohexane. Alright, so I hope you are being very clear. So zeotropes can be considered, there are some exceptional cases, but then generally they are considered as ideal solutions, and azeotropes are considered to be non-ideal solutions. Alright, we move to the next one. As I said, we'll be discussing slightly in detail with respect to azeotropes in terms of characteristics as well as uses. So let's begin with the characteristics. The number one is they are constant boiling mixtures. इसका मतलब क्या होता है? वो बॉयल होता है at constant temperature. एक फिक्स टेम्परेचर पे वो बॉयल होगा और वो बाहर निकलेगा, मतलब डिस्टिल आउट होगा पूरा का पूरा एक सिंगल टेम्परेचर पे without change in the composition. Okay, it will distill out completely. Okay, nothing will be left behind. So it will distill out completely. That means जो distillate जो हम बोलते हैं, जो डिस्टिल आउट होके बाहर निकलता है उसे हम बोलते हैं डिस्टिलेट. सो वो डिस्टिलेट पूरा का पूरा बाहर निकलेगा एक सिंगल टेम्परेचर पे. ओके, और इसके वजह से कोई चेंज नहीं होगा कंपोजिशन में. द सेकेंड पॉइंट इज द लिक्विड कर्व एंड द वेपर कर्व. दो चीजें होती है दोस्तों जब हम बॉइलिंग की बात करते हैं. सो देयर इज अ फेज ट्रांजिशन टेकिंग प्लेस बिटवीन द लिक्विड स्टेट टू द वेपर स्टेट. So in this case, because they are constant boiling mixtures, so both these curves, the liquid curve as well as the vapor curve, will meet at the same point. यानी इसका मतलब ये हो गया कि the vapor phase and the liquid phase are identical. Okay, जैसे मैंने आपको बताया था, there is no change in the composition. So इसी वजह से यहाँ पर भी हम ऐसा बोलेंगे कि जो लिक्विड का कंपोजिशन और जो वेपर का कंपोजिशन है वो सेम है, और इसी वजह से दोनों कर्व एक साथ मिल रहे हैं एक सिंगल पॉइंट पे, एंड दैट्स व्हाई वी से द वेपर फेज एंड द लिक्विड फेज आर आइडेंटिकल. नेक्स्ट वन इज पॉइंट नंबर 3. वी से इज सिंस azeotropes are constant boiling mixtures, their components cannot be separated by fractional distillation. दोस्तों ये देखो, ये देखा आपने, it cannot be separated by fractional distillation. दोस्तों fractional distillation is a technique of separation of two or more liquids based on the difference in the boiling point. लेकिन यहाँ पर दोस्तों मैंने बोला है कि it is a constant boiling mixture. देयर इज नो डिफरेंस। तो अगर डिफरेंस है ही नहीं तो फिर हम किस तरीके से उसको सेपरेट कर सकेंगे? बिकॉज सेपरेशन इज बेस्ड ऑन डिफरेंसेस, इट्स नॉट बेस्ड ऑन सिमिलैरिटी। दोस्तों सिमिलैरिटी की वजह से तो वो एक साथ जुड़े हुए हैं, हमें तो उसको अलग करना है, तो अलग करने के लिए हमें डिफरेंसेस पे ध्यान देना होगा। फ्रैक्शनल डिस्टिलेशन एक तरीका है, इट्स इज वन ऑफ द सेपरेशन टेक्निक, बट एज everybody knows every separation technique is based on a particular principle. So this is based on the principle of difference in boiling point. But यहाँ पर because it is going to be boiling at constant temperature, so obviously there is no difference in boiling point, and therefore we cannot make use of fractional distillation for separation of azeotropes. I hope you have understood point number 3. We proceed to the next part. The composition of the azeotropic mixture depends upon the pressure at which the pressure swing distillation is carried out. My dear friends, आप जानते हो कि बॉइलिंग पॉइंट प्रेशर के साथ जुड़ा हुआ है, क्योंकि बॉइलिंग पॉइंट का डेफिनेशन ही है कि इट इज द टेम्परेचर एट विच द वेपर प्रेशर इज इक्वल टू द एटमॉस्फेरिक प्रेशर। सो हम फ्रैक्शनल डिस्टिलेशन से सेपरेशन नहीं कर सकते हैं, क्योंकि वहाँ पर फ्रैक्शनल डिस्टिलेशन इज बेस्ड ऑन डिफरेंस इन बॉइलिंग पॉइंट, सो वी कैन नॉट डू दैट। लेकिन हम इसको डिफरेंस को दूसरी तरीके से देखें तो हम एजियोट्रॉप्स को सेपरेट कर सकते हैं बाय अनदर टेक्निक कॉल्ड एज प्रेशर स्विंग डिस्टिलेशन, जहाँ पर वी कैन ब्रिंग अबाउट द चेंजेस इन द प्रेशर, okay, we can bring about the changes in the boiling point, okay, and thereby we can carry out its separation. So the composition of that azeotropic mixture, okay, what that azeotropic mixture is made up of can be correlated with the pressure at which the pressure swing distillation is carried out, okay. And as I said, fractional distillation of azeotropic mixtures cannot be used, it cannot change the composition, क्योंकि जैसे मैंने बोला है कि the entire distillate comes out at a single temperature, and that's why the composition of the mixture which was being subjected to the fractional distillation and the composition of the distillate which comes out after the fractional distillation remains the same, and that's why we say it does not change the composition. All right, so this, my dear friends, are the 5 characteristics of azeotropes. I'm sure you have understood this. We now move on to the next segment, and that is about the uses. कुछ simple uses बता देता हूँ इसका, and that is, first one is, let's consider HCl, okay, dilute HCl as well as water का mixture हम लोग consider करेंगे. Now it contains 22.2% of HCl. It boils at 381.5 Kelvin. Pressure is 1.013 into 10 raised to 5 Newton per meter square. That's basically atmospheric pressure. Now, if the solution contains less than 22.2% HCl and that is distilled, then what will happen is water will distill out as a distillate. Okay, water distill out हो जाएगा पहले, और जो बचेगा जिसे हम लोग बोलते हैं residue, उसमें क्या रहेगा? HCl. So the residue will be richer in HCl. Okay, कब तक? Till the concentration increases to 22.2%. And therefore we say in a dilute solution, okay, क्योंकि मैंने बोला if the solution contains less than 22.2% of HCl, मतलब obviously it's a dilute solution, तो हम क्या बोलेंगे? HCl becomes stronger. ठीक है, अब इसका ऑपोजिट करो, हम ऐसा मान के चलते कि हम एक सोल्यूशन लेंगे जहां पर द कंसंट्रेशन इज मोर देन 22.2%, ओके, तो यहां पर HCl will distill out as a distillate, और बचेगा क्या? पानी. सो द रेसिड्यू विल बी रिच इन वाटर, एंड देयरफॉर ये HCl जो है वो कॉन्सेंट्रेटेड है, क्योंकि द कॉन्सेंट्रेशन इज मोर देन 22.2%, सो इट इज कॉन्सेंट्रेटेड. तो कॉन्सेंट्रेटेड HCl में इट बिकम्स पुअर, okay, and therefore HCl becomes weaker. So remember this, dilute solution में HCl is stronger and concentrated solution में HCl becomes weaker. Alright, this is what we consider with respect to azeotropic mixtures. दूसरा पॉइंट है, वाटर और अल्कोहल एक azeotropic mixture है, where the concentration of alcohol is 95%. The mixture will boil at 341.2 Kelvin. The maximum concentration obtained for alcohol cannot be beyond 95%. 95% के beyond वो जा ही नहीं सकता, और इस वजह से हम इसको बोलते हैं absolute alcohol. नाम तो सुना होगा आपने. So absolute alcohol is not 100% alcohol, it is 95% alcohol. और जो 5% वाटर है दैट इज रिमूव्ड बाय डिस्टिलिंग इट विद व्हाट, बेंजीन। क्योंकि आप जानते हो अच्छे से कि वाटर और बेंजीन दोनों का बॉइलिंग पॉइंट अलग अलग है, और इस तरीके से हम बेंजीन का इस्तेमाल करते हैं टू रिमूव द रिमेनिंग 5% ऑफ वाटर। ऑलराइट, वी मूव टू द नेक्स्ट पार्ट। द थर्ड एंड द लास्ट वन इज पर्सपिरेशन। जो स्वेट होता है वो भी एक एज़ोट्रॉपिक मिक्सचर है which contains 99% of water and 1% is fatty acid. The fatty acid is removed from the surface of the skin by fractional distillation. क्यों, उसकी वजह क्या है? क्योंकि जो boiling point है sweat का, that is mixture, is much lower than water as well as fatty acid. So there is a difference in boiling point, and therefore we can make use of fractional distillation. Alright, so these are, my dear friends, certain applications with respect to azeotropic mixtures. So I hope you have understood this session where we spoke about zeotropes, which we correlate with ideal solutions, and then we talk about azeotropes, which we correlate with non-ideal solutions. We considered the 5 important characteristics of azeotropes, and then we discussed few of the applications of azeotropes. Alright, so I hope you have understood this very well. I sincerely thank you for being with me in this particular session. Until we meet next time, do take good care of yourself. Sign off from now. Bye bye.